Yeah, here we go. Okay.
Okay, sorry. Okay, okay.
Okay, good now.
We're good now.
Okay. Okay. Great. Okay, so today I'm going to sharing the three location. So firstly, I show the blue line extension for the base trap station, Saranchai, for the chemical grouting. And second, so I will demonstrate for the orange line is U1 and U2 project for the jack grouting. So we can see the chem grouting. So for the video, so this first one is for the inner tube through the double packer. Okay. So the second one is for the double packer in the injection in the through the slip pipe. So for the construction sequence, firstly, for the drilling, so we're setting up the drilling machine, installing the drilling pipe drilling to the desired level. And the second, so we will do the seal grout, put the grout pipe to the bottom of the seal grout through the casing. And the third, so we will install the temp pipe in the design location. And the fourth, we will remove the casing pipe and wait for the seal grouting for the curing. And after curing the seal grout, so we carry the first stage of the CB grouting, cement bentonite for the initial first stage grouting. And the second, so will be the second stage for the chemical grouting. So after finish the second stage, so we will put the pressure melt. And if necessary, we will do the third time for the first stage grouting if necessary. So we can see the photos. First photo is on the setting up of the machine. And the second is the drilling condition. Because after finish the drilling, so we'll be check the drilling depth. After checking the drilling depth, so we will fill up all the seal grouting in the casing. After filling up, we'll be installing the temp pipe. And after pour the casing and the curing, so we'll carry out the chemical grouting and CB grouting. So this is the quality control table. So before work, during the work, and after work. So before the work, so we need to drilling up, installing the temp pipe, and checking by the level and also the take. During the grouting, so we firstly checking the mixing proportion for the CB by the mud balance, and also the chemical by the MK will be checked for the pH paper. For the grouting work, we will check the flow and also the pressure during the grouting of the CB and MK. And after finish all the grouting work, so we will do the permeability test or pumping test. Okay, so this photo we will see the video for see the jack, how the jack grouting. So this jack grouting, is a double nozzle with the double tube system. Okay. For the jack grouting, so we have three finger theory. So one is a horizontal jet with the pressure the cement mill, and rotation and lift up and form a pile. So we can see the drilling. So we have the direct drilling and drilling to the design depth, and also with the rotation lift up to form a pile. For the rapid jet system, so we have the R1 and R2 system. So for R1, we have 2 meter to 3 meter with the different lifting rate and to form the different diameter. So for the R2, so we can form 3 meter to 3.5 meter with different flow rate and different lifting time. So we can see the jet grouting for the rapid jet system. So for the photos, we can see the drilling condition. And this is also we can see the photo, the video for the. Okay, this video is a photo of how the jet grouting condition during the jet grouting. So this is a good quality control for the flow rate for the during the jet grouting. And after finish the jet grouting, so the spoil handling is also one of the key points. And after that spoil handling, so we will carry out for all the quality tests to confirm the quality control. For the jet grouting repair system, we have been carrying out all the trial testing in Taiwan, Vietnam, Singapore, Thailand also. So we can see that after we finish the trial test, we will excavation to confirm the pile diameter and with different soil conditions. So this is for the MRT Pool 9. So we have been carried out for chemical grouting. So the problem to be solved. So firstly, for the BS12 station, due to the insufficient thickness of the steep clay, so we have been designed for the chemical grouting for this project. So for the countermeasure, so we will increase the weight of the excavation base and reduce the permeability of the base soil, and chemical grouting for the base seal was adopted. So firstly, we will carry out the drilling. And secondly, we will do the carry out for the blanket grouting for the base grout. And after that will be excavation. So we can see this is the base 12. So in order to shorten the excavation time, the site, we divide into 4 works areas for the construction. So the stage totally for the quantity, we have about the 20,000 cubic meter of soil going to improve and 2,322 holes for the drilling. So for the first stage, we do the cement bentonite grouting with a flow rate 8 to 10 liters per minute and with the bottom ratio 8%. The second stage, we kill the MK grouting, the same flow rate 8 to 10 liters per minute with the bottom ratio 32%. So the drilling machine also modified to operation in the high limited space area in the station. So standard one is about 7.12 meters for the length. Due to the site condition, we modified the drilling for the drilling machine to 4.8 meters in order to suit with the station inside for the drilling. So totally 8 number of drilling machine was operating on the same time. So we can see the photos is working under the ground in the station. So how to perform the grouting work? So to ensure the homogeneous of the grouting body, the grout hole were arranged in the triangular way and prevent the ground heaving to ensure the homogeneous of the grouting body. So we have been carried out 8 to 10 liters per minute of the grout flow was adopted. The ground pressure distribution diagram was made to confirm the grouting quality, and if necessary, the first stage of grouting was operation must be carried out. So to perform the grouting work, so the pressure map we have been carried out to confirm which location, so the weaker pressure, we need to carry out the first stage. So in that project, so the first stage checking grouting was carried out to confirm the quality. So the photo you can see in here is the 24 to 36 numbers of the ground equipment was operating on site at the same time. So for the left-hand side, we can see the chemical mixing machine, what we say the ACRO. And in the middle of the photos, we can see the pressure and also the flow control. And we have the flow meter to all the record, all the pressure and also the flow. So you can see all the 2,000 hole grouting on under the ground of the BS12 station. So after finish all the grouting, so we will carry out the permeability test and also fuel pumping test in the station. So this is site condition after finish the grouting during the excavation. So you can see the bottom is quite dry in the same condition. Right. So this is under construction, and this is a project completed. So the second, so we talk about the MRT Orange Line recently. So this is a location for the OR 15 station in Orange Line. So in the OR 15, so we have solved the problem is that due to the expressway might be damaged due to excavation of OR 15 station. So we have carried the 2 layers of the proceeding beam. So the jack routing proceeding beam was installed to minimize the movement of the expressway during the OR 15 station construction. So we can see the top layer is on the soft clay layer. The second layer is the sand condition. Yes. So this is the location and also the quantity of the work. So we have totally 6 numbers of the proceeding beam with a width about 6 meters and then to construction before the excavation of the station. So this is during the performance of the boring work in the OR 15. So we can see the grouting, the jetting, and also the boiling pump location. So before the jet grouting, so we will carry out a trial test to confirm the design and planning, also the setting up the site, and also the checking the parameter is correct or not. So this is the what we say the JWM jetway monitoring test. So this is what's carried on the job site to confirm the diameter and also with all the record. So we can see on the left hand side here, so we can see this the monitoring. So they put under the ground to hearing the sounding. And this is we observe and receive all the sounding and put on the chart record. So we, according to this JWM system testing, so we confirm the peak point, we observe and record to confirm the power diameter. So this is the location we're testing for the 3.5 meter diameter and also 2.5 diameter using the jet monitoring system testing. So this is a site condition after we testing, and we carry out for the unconfined component test. This is the result for the testing. So after the jet grouting also, we carry out the result for the electrical resistance test to confirm. So we can see this color to confirm the 6 meter of the ground treatment zones with size. So you can see the photo, we have the visual inspection. So you can see the diameter after we jetting. So the top, the photo number 1, we can see on the soft clay layer. So we can perform the 3.5 diameter of pile. And second photos, we can see this is the second layer for the proceeding beam. Sorry, it's on the top, the bottom of the first beam. So we can see all the jet grouting diameter and the location of the performance. So second, for the orange line, so we have been carried out for the E1 and E2 for the construction for the orange line here. For the E1, the TBM tunnel is about 3,200 meters and cut and cover tunnel is 1,500 meters. And consists of the 3 underground stations and 4 intervention shaft and 2 ventilation shafts. And for the E2, for the tunnel TBM tunnel is about 3,600 meters and 4 underground stations, OR 16 to OR 19, and totally 3 shafts for the intervention shaft. So for the 2 contracts, E1 and E2 for the launching and arrival, so we have the soft eye 26 location and also hard eye and 14 numbers location. The E1 and E2, the ground treatment volume, totally the jet grouting is about 946 numbers of jet grout pile, and the soil volume is 2,000 29,940 cubic meters. For the temp grouting, the total is 1,328 numbers. For the soil volume is 54,154 cubic meter was carried out. So the problem to be solved in here, so this a different type of soil condition and different. So we have been prevent for the collapse or leakage of occur during the launching and arrival of the seal machine. So this is a typical for the sketch for the ground treatment port and seal machine for the TPM machine for the arrival and also for the launching protection. For this project, so we have different two type of the for the design for the soft eye and hard eye. So this is for the hard eye. So for the launching, so first of all, we will carry out the track grouting first, and after that, we will do the excavation from the working shaft. And after finish the bottom, so we will go to dismantle for the diaphragm wall for the hard eye with the cutting out all the reinforcement bar. And after finish, take out the diaphragm wall, and then we will install the entrance parking and prepare for the launching of the TPM. And then we can drive for the launching for the TPM. For the arrival, for the seal machine for TPM for the hard eye, so firstly, we jack grouting and excavation for the working shaft, and also removal of the diaphragm wall reinforcement bar, and also construction for the chamber box. So we can see for all these photos on the left hand side, so the construction of the chamber box after finish the TPM arrival. So we will dismantle for the chamber box, and we can see the condition of the TPM arrival. So the second case is for the soft eye, is by the FRP carbon fiber. So this diaphragm wall, so also we have been using for the jack grouting first, and after excavation, for the launching, we will install the entrance parking, and we'll prepare for the TPM after the assembling, we will launching directly. So we can see on the left side, so this is the entrance parking for the installation, and also prepare for the for the launching. For the arrival, for the soft eye, with the FRP, so we carry out the jack grouting first, and also this excavation. And when the TPM will be driving, directly to the station or the working shaft. So we can see the video. This video is in the Orange Line project for the OR17 station. So we can see the TPM slowly coming. So this is without the entrance parking, the machine will direct go through the FRP diaphragm wall. So for the TPM, for the arrival and the launching, so different soil condition, we have a different design. So we can see in typically the Bangkok, the top layer is the soft clay, and in the middle we have the medium clay and also the stiff clay area. So different soil condition, we have a different design, and for all the launching and the arrival. So this is a typical layout for the OR15 for the TPM arrival. So we can see the OR16. So we can see the tunnel in the first and second sand. In this case, for the stiff clay, so we skip for the jack grouting. So we only jack grouting on the concentrate on the sand area. So this is one of our typical design for the TPM, for the layout for the OR16. So we can see again, so in the launching and the arrival, so this TPM For the arrival, so we have been only designed for the medium clay only, and also on the bottom for the first sand. So the design for this one, so different soil condition, we put different jack routing design, and then for the launching and arrival area. And we can see why the stiff clay we are not to design for the grouting. So you can see in the photos for the stiff clay. So you can see the stiff clay is quite stiff, especially in the Bangkok. Okay, in the same condition during the drilling, we can see we can compare. So drilling is quite smoothly. We found the stiff clay area in here. So you can see different soil condition. We will put a different design for the machine, for the launching and the arrival. So this is the ceremony for the arrival of the seal machine in the Thailand, Bangkok, for the Untitled OR-17. So thank you for this. So thank you for your attention. So,
Okay.
sorry.
Okay. Thank you, Mr. Wong. Okay. So now let's open the floor for questions. I do have one quick question. Mr. Wong, on your slide, around number 42, you talk about the TBM break-in, breakout. And then, so in the back side of the diaphragm wall, and then you would put in the jack grouted area to seal it, right? To prevent water.
Yes.
Have you run into a situation where the grout itself is okay? However, when you do the break-in or breakout process, and then you still have the leakage, and what could that be the reason why?
Okay, this is a good question. Actually, so I skipped the step because before the launching the seal machine, we have the horizontal checking for the diaphragm wall. Behind the diaphragm wall, so we have checking any water path for leakage before the launching of the TBM. So after we setting up the engine parking, and then before we go to the machine for the launching, so we have checking for the any water leakage between the jack grouting stone and also the diaphragm wall, and the gap for the leaking or not. This is the we need to check before the TBM launching. Thank you.
Okay, thank you. And then we do have one question in the chat box. Can you read that in the chat box, or you want me to read it to you?
Where for the jack grouting stone usually to be used, including launching and arrival, what's the design criteria condition? Okay, it's a good question. So I think for the our design based on the Japan Jack Grouting Association and also Rapid Jack Grouting Manual inside. So we have discretion for different soil and also different calculation for this launching and arrival. And also we have the minimum size for the design. So I think if you can send me the email, and then I will give you the design calculation and also the typical for the requirement for this launching and arrival. So please give me the address. I will send you the menu for this one. Thank you.
Yeah. Okay. Thank you.